So, welcome to the last session of the SQL training, guys. So, today we are going to see a lot of real life use cases, the real life scenarios. How should we approach while building a project, right? Real life project or real life product when you start building for a database based application. How should you go about it? So, the focus is more on data modeling. Okay, so data modeling today I'm going to focus, and also I'm going to focus on how should we approach a problem, how should we approach a problem solving, okay, especially for interview or maybe in the real life before you write SQL. Okay, so let me start with, okay, this is the agenda for today. So we will just revisit what case study that we have gone through for the entire training, and the offline assignment review also. Okay, so classroom case study. So this is a case study, right? I don't want to repeat, but I just wanted to say briefly that we built a database in the sense we created a table, we created database first, and then we created four tables for populating values, item, and then the item receipt. Okay, so all this information that we kind of captured, and then we also created for supplier. Right, these four table we created, and then we used it for our analysis. Okay, and we solved around 50 plus business questions. 50 plus business questions throughout our training on those table and those data. Okay, and we kind of started right from basic to all the way to little complex, using common table expression, using ranking functions. Okay, so all these things that we have tried, right? I just tell you again that no, keep repeating, keep practicing, right, with these questions. Maybe you can go through the recording also, but I would strongly recommend, in case if you want this entire course, no, if you want to repeat, watch it again and again, then you can download it from the Google Drive. Okay, so because maybe after a week's time, probably this may not be available, the Google Drive no, will not be available. So right, so you take 1 week, within 1 week try to download these videos into your local system. Okay, and yeah, so I will tell you the other things later. And then offline assignment, so I hope the offline assignment, you guys tried, whoever tried got the benefit of trying it out on your own, right? So practicing on your own by creating two tables, vehicle table and shipment table, and you are practicing the similar question that I was giving at the end of every class. Okay, so this is something that we tried. Okay, so any question on the analysis? I think so. Here, as Lakshmi requested, kept sharing the actual offline assignment sequel, so that you guys can also refer that. Okay, so I hope that was useful for you to verify and validate. Okay, so I hope the offline assignment sequels were helpful to you to verify and validate the sequel that you guys were trying. Okay, and I also provided data. Okay, so let me pause here. I just wanted to hear from you guys. The Can you briefly talk about the classroom case study and offline assignment? Right? Any question or generally your comment or your feedback? Did it help you, or no? Can you guys just talk about these two, offline assignment and the classroom case study?
And the case study was pretty easy to understand and simple. I mean, we could relate to it. It was not something complicated to understand. So, as and when you took up some examples and explained it with the case study, I think it was easier to understand the concepts. And the assignments definitely helped. I mean, one thing, for a few assignments, what I felt was I delayed it. I did it the next day. So that time I had to actually go back to your examples, I mean, read through a few and then do it. So I think fresh, right after the class, if we take up those assignments, I think those concepts are
Okay.
fresh in our minds and it's easily registered.
Okay. Thank you for your detailed feedback, Janakram. So, anyone else wants to share about your feedback on the case study, the classroom case study, the practical, right, the case study that we were going through, or the offline assignment? How many of you, anyone else have tried continuously, no, every after every class? Yes, over to you, Karthik.
So basically, I'm a slow learner, but still, I'm in the class eighth table al- alternative. So,
Yes.
but the case study is good, but still, I just tried in different scenarios and try creating in different areas like whichever related to my current organization.
Okay,
Those.
okay.
So it's and moreover, I tried everything in my system like till the last class, and still I'm learning deeply because I just started very slow and learning very slow.
That is
So
okay. I think slow is also
what I did,
fine, but yeah, as
yeah,
you said, that practicing it regularly will make
yeah,
you.
yeah. Thank you, sir.
Okay,
Thank you.
okay. Thank you, Karthik. Anyone else? So Pavitra, especially now, I would like to hear from Pavitra. How did this, yeah, help you?
This helped a lot. As coming to assignment, I'm pretty much busy with two kids. Sometimes I didn't get time to practice.
Okay.
As Janakiram said, after finishing the class, if we do assignment, it's very easy to understand and to do very fast
Mm-hmm.
also.
Okay.
If not, if we missed one or two assignments, we have to go back to the classes, have to listen
Mm.
carefully everything,
Yeah.
have to understand, have to practice. Maybe because of lack of practice, for me, I have to take some time to
Yeah.
practice this all again.
Understood. Yeah.
Thank you.
Okay. So I think yeah, the key element here is practicing. Listening and other things are there, which is a good starting point. But practicing, yeah, obviously, right. So practicing will, right, register in our memory very strongly, right, so that we remember it for a long time. And what about you, Vijay, B. Vijay Kumar, or Naveed? So Naveed, how did you find? நீங்கள் உங்களுக்கு டைம் கிடைச்சதா? Did you get time to practice? Or Vignesh?
Yeah, sir. Actually, last three class practice பண்ணி பார்த்தேன் பட்
Okay.
இப்போ ஒர்க்கு கொஞ்சம் கண்டினியூஸாக வந்ததுனால ஃபோக்கஸ் பண்ண சார் அகெயின் நான் மறுபடியும் ரெக்கார்டிங் வீடியோஸ்லாம் நான் பார்க்கேன் சார்.
Okay.
சார் பார்த்துட்டு ஒரு டைம் ப்ராக்டிஸ் பண்ணணும் லாஸ்ட்டு ஒரு 5 classes மட்டும்.
Okay.
ஸோ இப்போ எதாவது டவுட் இருந்தால் கூட நான் ட்ரை பண்ணுறேன் சார்.
Sure. Yeah. Thank you, Vignesh.
ஆக்சுவலி எஸ்டர்டே ஒரு என்ன டவுட்னா ஆக்சுவலாக அவங்க வந்து எக்ஸ்எம்எல் ஸ்டோர் பண்ணுறாங்க சார் அந்த காலத்தில். ஸோ வந்து அது வந்து டெக்ஸ்ட்டு கேரக்டர் வச்சுருந்தாங்க. நான் அப்புறம் ஸ்டேஜிங்கில் ரீஸ்டோர் பண்ணி அதை வந்து எக்ஸ்எம்எல் டேட்டா டைப்பாக மாற்றி எக்ஸ்எம்எல் இண்டெக்ஸ் கிரியேட் பண்ணி ட்ரை பண்ணி பார்த்தேன் சார்.
Okay.
அது
So
குட்டா சார் அந்த
good. I think start experimenting. So whatever that assumption you have or something that you want to try, if you have a no dev environment or test environment, sandbox environment, if you have, you would practice it, so that you can see, okay, is it improving? Is the performance is better improving or not?
குட் சார்.
Okay.
ஆக்சுவலி 40,000 ரெக்கார்ட் ஸ்டோரிங் சார்
Okay. Okay. Thank you,
சார்.
Vignesh. Okay.
சார் நெக்ஸ்ட்டு பர்ஃபார்மன்ஸ் கிளாஸ் எப்போ ஸ்டார்ட் பண்ணுறீங்க அப்போ அப்டேட் பண்ணுங்க.
Sure. Definitely, I will update whenever I start the performance tuning no, class or data warehousing class. Okay.
தேங்க்யூ சார்.
Yeah. Thank you, Vignesh.
சார் நல்லா எக்ஸ்பிளைன் பண்ணீங்க சார். தேங்க்யூ சார்.
Okay. Thank you, Vignesh. Okay. So now I'm going to start with the real life use cases. Okay, it's extremely important for you guys. You guys know SQL now, right? But I don't want to leave you guys with just knowing SQL. Okay, so that's why I want to start with the real life case study, so that you guys know how to approach, how to plan, and how to approach a real life project. Okay, so the first project that I'm going to talk about is for a restaurant. Okay, this probably, I don't know if in case if you guys have seen my YouTube, you would have seen this real life use case wherein we build we plan and we model, we design for a restaurant. Okay, we do it for a restaurant. Okay, so in this case study, a chain of restaurant wants to build an application to capture, store, process, and report their daily business transaction. What is a business transaction? It is customer visit and ordering, right? In a restaurant, the important information is order, capturing the order. Okay, so let me pause this video so that there is no bandwidth issue. Okay, so what is important, right? So who is coming and what all items are there in the menu card, right? So these information we should be able to capture. So for that, I'm going to help you how you should design a database for a restaurant business. Okay, so what is the starting point? The starting point for any application is the real life, because it has to start with real life, right? So ultimately, whatever that we are building needs to be or will be used by real life person. Okay, so real life business. So that is the starting point and end point. Okay, so for the starting point, we need to first identify in a restaurant what all are the basic data elements. Okay, that is also called entity. First and foremost thing is we need to identify the basic data elements involved, right? So for that we need business process documents, business process reference. So in a restaurant, what all are the business process document? There are two documents are important. One is the menu card, right? One is the menu card, and the second is the actual bill that they give at the after for the payment. Okay, so the first is the menu card. It will have the category of items, and then it will have the list of items, and then it will also have the price. Okay, it will have the price, and it also has the quantity. If you see idli 3 pieces, right, and vada is 3 pieces or 2 pieces, so whatever is the number of quantity also, right? So number of unit. So this is one input that we need. Then we know, okay, what all are the items that this particular restaurant serves and what is the price. Okay, and then when they order, right? So when the customer makes an order, so we deliver the food and they have it. After finishing everything, we are supposed to produce an invoice or bill so that they know what is the total price and they will make the payment, right? So this is one example bill. It gives the restaurant name, restaurant address, and it also gives the date, okay, when they had, and what is the bill number on that day. Okay, every day they will generate starting from 1, they will start the bill number, and this is the table number, right? So if they have 10 tables, which table that they are having. This is a waiter number, right? What is the waiter number? Who is serving? Okay, at least so that we will know, we can do some analytics based on the waiter also. And then the what is that we are ordering, right? So it's a pav and it's a vada, okay, medu vada, right? So and then coffee. So basically it gives the list of items that this person consumed along with the quantity and what is the price per item, and then the total total amount, and then the overall amount, right? So if this is the individual item amount and this is the overall total amount, and this is what will be given. This is what will be given to them and they will make the payment. Okay, so now how are we going to capture this information? How are we going to design a database for this use case, right? So we need to first capture the basic data elements. For basic data elements to capture, you need to always ask this question: when, where, what, who, right? There are what, how much. So all these questions that you need to ask, basic question, right? So this will give you how much the price is there, what they are serving. So here the snacks items are there, here the list of items are there, right? So then the first and foremost thing is the restaurant name. Because as I mentioned, it's a chain of restaurant. They may have 4 branch or 8 branch, 10 branch. So we need to capture, right, which branch, which restaurant this particular transaction is happening. Okay, so the restaurant and along with it, its address. Okay, second is the menu card, right? So menu item. So it's a list of items that are being served along with the price and the quantity. Third is the customer. Okay, customer is the one who is actually visiting. Right, nowadays they ask the mobile number or no, maybe credit card number. Through that they will find out. So there are various mechanisms, but they will be capturing the customer information who is visiting. And finally, the last one is the order. Right, so it's order, what they are ordering from the menu item, what all there that they are ordering. It captures these four informations are needed. Okay, so that's what we are right now capturing. One is the restaurant name, menu card item, and then customer who is visiting, and then the order. This is the entire order. Okay, what, who, all the information. Any question so far? All right. So I'm just moving on. So the same information we need to expand it, expand the data elements, right? Slowly we need to expand. Okay, when means date and time, where means place, address, city, what means okay, what item involved or what, right? And what event happened, what is the price, what is the quantity, item. Here in this case it's item, right? So item is also it's a what is served, what was served, right? So who, the person, contact number, email id, in fact yeah, the customer details. So based on that, what we can do, we can create a simple details, expand the details. Okay, item means, okay, the item type will be there, tiffin item, then idli, and then rate. Only these basic. So start with the basic, guys. So always whenever you design for your prototype or pilot, or when you are doing for your practice, start with a simple table. Okay, simple entity first, basic elements. Don't overcomplicate. Okay, and then restaurant also, okay, the name, city, and when they opened. Okay, customer means name and phone number. Email also some not nowadays not being captured. It's a phone number is very important nowadays. And then order header. So order alone we have to capture as a two tables. I will show you. I'm going back. Yeah. So in this table, if you see the order, even though it's a single sheet, right, single bill that we get, it has two levels of information. You see, this is one level of information. It's a header level information, right? For the entire bill, it's only one data, right? Date means only one data, order date. Table means only one table, right, that we will be sitting, main table where we are sitting, right? And the waiter, the main waiter who served, bill number, right? So all these are more header information, and the total amount is also header. But this information will be multiple, right? Could be one item, it could be 10 items also, 10 records also. In case if there are too many people come and eat, it could be 10 items also, right? It's a varying. But this granularity is different from this granularity. This is order level. The granularity is order level. This granularity is item level, line item level, line level, right? So we need to split into two tables. One is the order header table, second is order details table, right? So that is what is the, you need to think about. Okay, in any project, is it a single table, is it a two table? Order header, order item. Order header will have order id, order date, restaurant, customer. Okay, so who ordered, and which restaurant they came and had, and what is the order date, and the order id, unique order id. This, so if you see here, it will be unique order id. Every record will have only one id. It's a primary key. Okay, whereas in order item table, okay, the order id will be foreign key, because for this order, okay, there are two items, three items, four items, any number of items, multiple items will be there. Okay, first item is puri, second is coffee, the quantity, and then the price, item amount, everything will come. I've just only put a few columns here. Okay, so those information we need to go. So right now what we have done, from one simple entity, we have expanded the data elements. We have expanded the data elements. Okay, so restaurant, so this is how we can put it. So now we are ready for conceptual data model. Conceptual data model is a data model which talks about the relationship between the entities. Relationship between the entities, okay, at a high level, at the conceptual level. So that's why we have only the box restaurant, item, order header, order item, customer. These 5 boxes will come. Now we need to say restaurant to order header. Is it? What is the relationship? We have seen relationship, right? Cardinality, one to one, one to many, many to one, many to many. So from that relationship point of view, we need to say from restaurant, one restaurant can have many orders. That's why one restaurant can have many orders. Similarly, one customer can place many orders. He will come for not today, and after 1 week he will come, or he will come every day, or he will come in the morning for breakfast, afternoon, lunch also he may come, right? So one customer will place many orders, not same time but different times, I am saying. Similarly, one order will have many items. We have seen, right? He ordered puri, coffee. One order will have many items. Similarly, one item will be part of many orders. One item will be part of many orders. Okay, so one item will be part of many orders. Okay, so we need to first come up with this conceptual data model. Okay, once we come up with this conceptual data model, we will go to logical model. So any questions so far? Okay, so I am slowly expanding that table, each table with a column. Okay, now we will be thinking, okay, what all key columns, key column and other columns, important columns, right? For restaurant, if you see, it is a restaurant ID needs to be there, name and city. Okay, and restaurant ID will be the PK, primary key. And customer table will have customer information, customer ID. And item table will have item related info. This is a menu card. Okay, these 3 tables are the reference tables, right? These 3 tables are the reference table or master table. Okay, because they are just created when setting up the business. Okay, on an ongoing basis they may have some maintenance, right? For example, customer they will be adding, but still this is a reference table. This is not a right, the yeah, this is a reference table, still it's a master table. Order header and order item are the transaction table, when actually some transactions are happening. Okay, when actually transactions are happening, either something is being delivered or something is being sold, right, in exchange of money. Okay, so what we are doing, we are capturing the order ID, restaurant ID and customer ID are the foreign key, right? These 2 are the foreign keys, and order date will be there, and order amount will be there, which I have not put it, right? So you need to will need to expand to all the columns. Similarly, the order item table will have order item ID, primary key, and order ID will be foreign key, and item ID will be foreign key. For these 2 combination we will be creating. Okay, this is what is called logical data model. When we think about logical data model, we don't think beyond the primary key or data type. Okay, we will only think from this point of view at this level, expanded the each entities with the data elements. And finally we will be creating physical data model. Okay, physical data model is based on the physical structure, which tool that we are creating. For example, now only we will be thinking, okay, are we designing for Oracle, or are we designing for MySQL, or are we doing this for Microsoft SQL Server? Okay, so we are coming to technology dependent thinking. So far the conceptual data model and the logical data model, we are not thinking anything from that point of view, but now we are thinking more of a technology based choice. So now we will think about the data type, what this supports. For example, not all supports the same thing, right? There will be few variation. So now we are thinking, what is the data type that I can assign to restaurant ID? What can I assign for order ID? Right? Because restaurant ID, I think tiny is also fine. I don't think we are going to have more than 255 restaurant. Right? Maybe for the safer side, we can make it as a small int. Right? We can go for 32,000. But integer is not needed. So then I can go for that. Whereas for order ID, I can go for int, or int is fine, because it will go to 214 crores. Right? So the int is fine. So like that, for each and every logical model, so this here columns we are going to think about, okay, what is the column data type that I am going to decide, right? So I will be doing that. and then I will think about the constraints. Okay, what is the relationship between these two? So should it be a not null? Should it be a unique constraint? Should it am I going to make it as an identity column where the automatically number generation is going to happen? Should I define any check constraint? Right, especially in this example, if you see the item category, whether it is a snacks, beverage, right, meals. So for those things I can make it as a check constraint. Okay, and then foreign key constraint also I can define. So all these things that I am creating based on the actual syntax of the system. And then normalization, right? So normalization would come already in the logical thinking itself, modeling itself it will come, not in the physical, right? So in the logical model itself the normalization will come. So initial data, so it is initial data is also called seed data. What is seed data here? Restaurant address, because when we open the restaurant we know, okay, even before the first customer visits. So the seed data is even before you start the first transaction, what all data needs to be there in the system. Reference data, restaurant detail needs to be there, menu card also needs to be there, we should have populated, right? Then only the first transaction can be created. Okay, so that is what is referred as seed data. And then DDL statement you will generate out of it, and then you will execute it. Then actually now only you will be creating. This is where we started our training, right? But before that you see all these activities are there. Okay, so what you learnt is this DDL statement you have learnt, and this DDML statements you have learnt, right? Creating a query, creating a view, use a different function, stored procedure, trigger. So all these things that you guys have created, and this also you have created. Application usage is nothing but the reporting, right? The business users will say, show me how many idlis sold today, this week, day by day, right? How breakfast versus lunch versus dinner, show me the profit by I think they may have some name, I don't know what is the name, by the thing time of the day, maybe breakfast, lunch or dinner, right? So all these things that we do, it's more of an application usage or application actually data reporting. I would say it's either usage or reporting. Okay, this is what is called reporting, right? So here is where the analytics comes. So this is where the database design is coming to the picture. This is where the database developer is coming to the picture. Database developer will be developing all this. If you are going to work as a SQL developer or a database developer, you need this, or application developer. You will do these two. Application designer, data modeler or architect will do this, and this a developer will be creating. This is where the data analyst, data scientist, and then the BI developer, those people will be doing. Okay, so these three is what extensively that we have learned. Okay, but before that there are so many activities are there. Okay, so with that, any question guys now on this first use case? I'm going to cover two more use cases, but I just wanted to ask you guys any question, comments? All right, so I'm going to go to the second use live case. Okay, second case study I'm going to start with. Second is for how are you going to design online ticket booking for app. Let's say if you are going to design online ticket booking app. Okay, so actually one thing that I don't know whether I told you guys, so all these are an idea right now. Whatever the real life use case that I'm sharing, I want you guys to start a project, mini project, a 1 month project. Okay, so wherein you will do end to end, right? Wherein you will do end to end, so which you can put it in your biodata or in your resume also you can put it. You can claim that you have done that as a project. Okay, so so that is one benefit. Another benefit you will get when you do end to end right from the scratch, you know your understanding will go really good. You will become really good, solid with SQL. Okay, so that's why I'm starting with these ideas. These are the some of the ideas that I want to share, but you guys can choose, right? It need not be IRCTC ticket booking, it could be normal online ticket booking, bus booking or movie ticket booking, can be any online booking. Okay, so I'm just sharing IRCTC as an example. When you design an IRC application like IRCTC, what will happen, right? So let's say the system should capture passenger details, ticket details, tickets ordered, master list of trains, stations, coaches. Right, all the information we need to design tables for these. Right, we need to design tables for all of these, and it should help them to generate daily report or some operational reports, like what is the most booked train, which train is famous, popular, most busiest station, which station many people are traveling, right? So number of passengers per ticket analysis that you can do, right? On an average, right, in a ticket, if you see, 5 people or 6 people is what maximum you can book, but how many people are traveling, what is the average, is it a 2 people are traveling together or 3 people, how many number of people are traveling together most often? Time of the day analysis, day of the week analysis, right? Which train is becoming more crowded, is it a evening night trains or is it a day trains, weekend trains? Station wise, coach wise, day wise, train wise, you can get breakup. Okay, so all this analysis you will be able to do. And then what is the business process? What is the business process? Okay, business process document is one second guys, one second. Yes, somebody is calling. Arjun, என்ன பண்ணிட்டு இருக்க? என்ன பண்ணிட்டு இருக்கற? செல்போனை பார்க்காதன்னு சொன்னல. Okay, so I'm back guys. Okay, so train ticket. Now we are going to see what all are the business process documents. So as I said, this has to start from the real life, right? So in real life, if we see the business, to find out when, where, what, who, we need some real life business process reference. So which is nothing but the train ticket. So if you see that train ticket, right, the printout will be a good starting point for you to start, right? So it has all the information. For example, what is the PNR number, what is the transaction ID, what is the from station, the train's starting station, right? But which station that I am boarding, my boarding station, reservation up to, okay, reservation up to is the last station that I am going, okay, and then passenger mobile number, important information, and the train number and name, it's a train related information. The traveling date and time of booking, this is a, you see, this is a date and time of booking, this is not traveling date, okay, and this is the date of journey, okay, date of journey, date of boarding. So sometimes date of journey and date of boarding will be, might be different. Date of journey means, for example, train might start at 11 p.m. one day, but you may on board 1 a.m. in the next day, so that's why this date of journey and date of boarding might be different, okay. And scheduled arrival date, okay, arrival time, okay. And then quota, which quota is a general ladies, what quota that you reserved, and what is a class of travel, right? It is a super sleeper class, first class, AC, right, whatever that you have chosen. So these are two stations till when the station train is going, okay, from and to, and scheduled departure time, okay, what time is starting, and then how many people are traveling, okay, only one person, and distance, okay, it's 1030 kilometers. And here this is a ticket fare details on payment related information. You see payment gateway, charge, right, how did you make the payment, all the information will be there. And finally you will have the passenger details. So based on this you will get an idea when you go through the actual document. For example, if you are going to design for a movie booking app, then obviously what you should do, you obviously use some app, right? Maybe by booking my show, book my show, or not ticket.in, so whatever you may use app, right? So there either you can look at the app just to figure out, or you just take the movie ticket printout, you will get an idea what all information needs to be there, because that's what the actual transaction is happening, right? So now coming back to this, so you know, when, where means no stations, when means times, what means the train, right? And which, yeah, maybe train, what class that you are traveling, right? Who, and here these two are information also, right? It's a booking status, right? Confirmation status S9, and what is the lower berth number, so all the information that you need to capture. So this is what I have just come up with, a conceptual data model, simple conceptual data model, okay. So ticket is the main transaction table. This is a transaction table surrounded by the reference, right? This is also reference. This, right? Station. So we need the station first. One station, one will have many tickets. Many people will be traveling from one station. Similarly, from one passenger might book multiple tickets, right? So around the year, if you see, he might do a lot of multiple travels, right? And one train will have many tickets, right? For example, 1,000 tickets or 2,000 tickets will be there in a single train trip. Okay, and the payment I will talk about later. The coach means the class. I think that it's a second class, first class, sleeper class, right? Sitting. So whatever is a coach. Okay, so based on now payment, right? So one ticket, one payment generally, right? So one ticket will have one payment, right? So you may make one payment, right? So for example, you will make one payment, right? So payment information will be separate because ticket information, let's say 4 people are traveling, there will be 4 records because passenger information also will be there, but in this table also there will be 4 passenger records will be there. The ticket will have 4 records, but payment will be only one record because for that, for all the entire total amount you will make one payment, right? So it will be one record. Now price list is more of a for calculation. So how the in IRCTC ticket price is being calculated based on the distance you travel, right? They will have the range 0 to 50 kilometers. This ticket price is 10 rupees. Maybe 50 0 to 50 60 to 100 means this 20 rupees. So like that they may have, right? But that also will change based on the class that you travel. Is it a second class, first class, AC, right? Based on that, we'll decide. So based on that, this will give you the ticket price based on the actual amount. It will give you, right? So based on that, you can calculate the total ticket amount which you can receive payment. Okay. So any question at this point of time for IRCTC conceptual data model?
So here, relation between passenger and ticket, isn't it many to many? Because ticket can have multiple passengers as well, right?
Ticket will have many passenger, yes. Ticket will have many passenger, yes. Yes, many to many. Yeah, you're right. You're right. So ideally speaking, we need to have split into 2 tables: ticket header and ticket details.
Got it. Okay.
Okay, ticket passenger, maybe ticket passenger, ticket travelers, whatever it is, ticket line number. So the passenger will generally will be pointing to ticket line number. Ticket will be ticket header.
Yeah.
Yeah, good one. Yeah, I think you got the idea of the modeling now. Yeah, so any many to many cannot be directly joined, right? It has to be joined through a bridge table. So here the bridge table is going to be ticket header. Yeah. Any other question from anyone? So in the ticket header, the primary key is the PNR number. So if you see in the ticket, right, PNR number is the uniquely identified. So we can use the PNR number as the primary key in the ticket header table. Okay, that's how it works. Okay, so from the logical, from the conceptual, you can go with the logical. Logical is expanding with few other columns, right? So that's what we do. The station, name, city, and here also name, phone number, passenger, maybe age. Also we can capture here. So whatever information that you think is needed, we can capture it here. Okay, and the train information also, and also type, it's a super fast or it's a passenger, it's a Sadapti or it's a Vande Bharat. So it's a what type of train it is, right? So we can capture because based on the price also changes, right? So based on the type of train, the ticket price also changes. Okay, and then the ticket information, ticket header, as we just now discussed, this should be split into 2 tables: ticket header and ticket line, right? This passenger detail will not be mapped to this packet. Passenger will be mapped to the ticket line details. Okay, and the from and to station. So in fact the station, where is the station? Here station will be mapped twice actually. Okay, station, because there will be from station and to station, right? From station and to station both will be there. Okay, so both will be there. So that is a little advanced data modeling, but I'm not covering that now. It will be confusing. That will come in advanced data modeling concept. Okay, so at this point of time, you assume it's a station will be there, but there will be two columns will be there, from station and to station. Okay, and after that a date will be there, order date will be there, and then start date will also be there. I think that I have not captured, but the departure date, right? Departure date, and in fact arrival date also we can keep, right? So in case if somebody wants to do analysis on arrival date, we can also find out, do analysis on arrival date. Time also, the right departure time we can keep as another column. Okay, and now similarly coach is also important, right? So the coach, whether it is a AC, it's a sitting, sleeper, right? So all the information that we can capture, it's a coach or class, right? It might be a class. Coach will be different, say S1, S2, S3, that's a coach. So this is more of a class. Okay, and then price list, so it's a kilometer range class based on the class, and a kilometer range based on the train type also. I think that also needs to be included. Train type super fast means the price will be different. Okay, there will be few other factors. And then payment, obviously payment will be payment ID and the PNR number. Okay, for this PNR we are making this payment. What is the total amount and what is the payment mode? Is it a online cash across the counter in the station, or it is a online, is it a UPI, right? So it's a credit card payment. And then what is the transaction reference number, right? Those information captured into this table, so that we can also do analysis on what payment mode people are preferring, right? So what more people are preferring, UPI, how the trends are happening, so right? So all these things that we will be able to do based on this. The physical model is exactly the same, which I am not going to cover. I am going to stop with the logical data model. Okay, so with that I am going to move on to the next case study. So in case if you guys have any doubt, let me know, otherwise I will be moving on to the next. Alright, so I am going to move on to the next one. The third case study, use case that I am going to cover is library. Okay, so library is a slightly different transaction. Okay, so library, what we do, we basically do checkout, right? We take the book, it's called a checkout, right? We check out the book and then we return. That's what we do. These are the two transactions, right? So what all we need to capture book details, we need to capture date, which day they checked out, which day they return, and number of books checked out, right? Master list of books, complete list of books, right? It's a the catalog of the books, and which will have the authors, libraries. In case if this software I'm designing for multiple library, then I can keep that information also, right? It will help them to find out how many books are checked out currently and how many books are available at this point of time at the library, right? Exactly how many books are available, right? Excluding the checked out books. Okay, and overdue books, I can find out how many books are overdue, and average return duration. Okay, by reader, which reader books people are taking lot of time. For example, maybe interesting, like people are returning after 10 days for this for this. By every reader we can find out, right? Some readers will return within 2 days, some readers will take 2 weeks, right? So we can do that analysis. And also the average return duration we can do on author wise also we can do, right? And the time of the day analysis, day of the week analysis, weekend versus weekday, library wise, author wise, publisher wise, journal wise, we can get breakup at a library, right? So let's find out what is a data element. First thing is, so I found out one checkout sheet in a library. What is a typical checkout sheet? So what is a student means user, right? So who is and what is their contact details, which book they have taken, on which day they borrowed, which date they returned, how many days it took to return. In case if it's an unreturned book, you will find the number of days till today. This is till today. Okay, so like that they can this is the actual library sheet. So from that, what all information that we can do, when, where, what, right? So this is what I've come up with at a high level. This is basic, this is not an exhaustive, right? So library, basically the library address, library capacity, the what is the size of the library, is it a government library, what is the category, what is the city where it is. So all the information that we can capture it, whatever is needed for our analysis, okay, we can put it here. Then we can also say user, right? User, the exact details like phone number, email id, name, right? So all these users that we can take, male, female, so that we can do analysis. Okay, what kind of people are coming to our library? Is it teenagers? Is it mid 30s, mid 20s, mid 40s? So we can do those kind of analysis if we capture the age. Okay, and then author. Okay, this is book is what we capture. Okay, so what is a book, right? Book is what will be they will be taking, but for a book there will be one or more authors, right? One or more authors will be there, and similarly one publisher will be there. Publisher wise, if we want to do analytics, we can also capture publisher. And one book belongs to one or two genre, right? It could be fictional, it could be non-fictional, fantasy, so all these things that they will. So if you want to do analysis based on that, you can also capture that as a separate dimension. And the librarian, right? So who basically giving the book? Who was the librarian at the time when the book was checked out? Okay, so that also we can capture here. And we will have the category. Okay, we will have the category of whether it is a subscription. So what's under what subscription this person is taken the book? Is it a student subscription? It's a paid subscription? It's a free subscription? The books how they are taking it, right? So library to checkout is many. One library will have, there will be many checkout on a daily basis, right? One user also will take many books, but there will be limits, right? Maximum 3 books, maximum 5 books, maximum 10 books. So for those kind of things that we can find out at any point of time how many books each person is having. And book to checkout, one book will be checked out multiple times also. After one person returns, it will be given to another someone else. And category also, right? Which category that they are taking. Librarian, one librarian might issue 100 books also on a given day, right? One author to book is one to many, right? As I mentioned, one book may have, one author will have many books, and one book will have many authors. It is actually many to many. Book to author is more of a many to many relationship, but book to publisher is one to many, right? One publisher will be having many books, but one book belongs to one publisher only. Okay, and genre also many to many. One book may have many genre. Sometimes they will tag, right? Nowadays they are tagging multiple also, but there will be primary genre. Okay, so this is the conceptual data model that we can start thinking and work out for a library. Any question, guys, on this? Alright, so I'm going to move on to the logical data model. Okay, I'm going to the logical data model. So here you see for author, you can capture what all information you want to capture for author, what all information you want to capture for publisher, which country. So in case publisher country wise we can do analysis, right? Author country also we can do. Origin, which country author? French authors are high in demand, right? Like we can say Spanish authors are books are in demand. So those level of information if you want to capture, then obviously you need to capture country for author. Okay, and then genre you can capture, book related information, right? So book also you can say the number of books. Based on that we can do some analysis. Is it a 600 days book, 600 pages book is generally taken for 1 week. If it is 1000, more than 1000 pages book will be taken for 2 weeks. And less than 100 pages, its average is 3 days. So like that level of analysis also we can do. Language, book language. If it is an English book, Tamil book, Hindi book, right? Language, based on language we can do analysis. Whatever you think is key, you can keep modeling it. Okay, user related information, librarian related information, librarian related, and subscription. So all the information that we can capture it here. Okay, so with that we have seen three different real life use cases. Okay, 3 different real life use cases which you can think and start as a mini project. Okay, right now we are in towards now end of or middle of January, right? We are 20th January. Probably you guys can plan for 6 weeks project. Now target to end by February end, right? You want any one of these, or you can choose your own from which is close to your office work. So in case I actually in one of my previous project, one person took up no, she was working in hospital, so she did that as a hospital. For her hospital, doctors write prescription, right? So that became her transaction, prescription, right? So that is what she kind of designed, did a project. Like this is similar to the first assignment, like restaurant, right? Going to hospital is similar to that, because there also they are serving, here also they are serving, right? So it's a similar model, right? So their item, here it is medicine. Okay, so you need to first have the list of medicine and then list of doctors, right? List of doctors we need to capture, and then the hospital details, and then the patient details, and then disease related information, right? So then finally the payment, right? The actual pharmacy, in case if you want to extend it. So like that you can plan. She did a project, right? And for one more person, she did a project for retail store, for a grocery shop. For a grocery shop, she did a project. This is again similar to a restaurant, right? So where we go and buy, we eat in a restaurant, whereas when we go to grocery, we will buy. It's more of a product, right? We will buy the product, but it's almost the same. Instead of item, so there also it will be an item. So we are selling the item, and there we will be having order header, order item. Yes, the same thing. Because if you visualize a big basket, in case if you guys are using big basket, or if you guys are using any Amazon, right, you can design your own online store or physical store as a small with 4 5 tables. Don't plan for a big 10 15 or 20 tables. Plan for 5 tables, less than 5 tables at the beginning, with a few columns, right? Important columns, right? Start with it, populate, and try to generate what all questions. So another thing that I told is, just go, in case if you are designing for, let's say, a retail store, you go to your house nearby any retail shop. If you know someone, just talk to them. What all metrics are important for them, what all reports are important for them, right? Just casually talk to them, right? If in case if you have any, somebody is working in hospital as a doctor, just maybe have some discussion with them, right? What kind of system they need, what kind of informations are critical for them for their day-to-day business, right? So that's how you should start your project, right? Okay, either it's close to your real life or it's close to your office, right? So that you will be able to relate it much better. Okay, so any question guys on this real life project? Okay, so all right. Now I am going to move on to the interview question. Okay, so we are moving to the last section of today, which is interview question. So what I'm going to do in the interview question, I'm going to pick up couple of interview questions, and I'm going to walk you through how we should approach. Okay, so we are given a table. So this is one interview question which you will find it on the internet. Okay, so what they are saying, this is more of an online transaction. So for example, assume this is taken from Amazon kind of online, right? Transaction ID, user ID, which date they ordered, what product they ordered, and how many quantity they ordered. This is a simple table, okay, sales table that they have. Okay, so what they are asking is, we need to query the number of users who purchased products on multiple days. Okay, who purchased products on multiple days. Note, a user can purchase multiple products on same day. That we should be excluded. We need to exclude. For example, if you see U1 has bought on 16th December, and one more transaction also is there. Different product he purchased, he or she, but both are same day, right? Other than that, there is no U1. So U1 will not come in the output. So that's why this is the output. If you see, U1 is not there. U3 also will not be there, because U3 also bought the, even though two records are there, but both belongs to same date. Whereas if you see U2 and U4 if you see has purchased on 16th and 18th on a two different dates. U2 if you see purchased on 16th and as per 17th, two different dates. That's why we are seeing the output. Okay. So can you guys think now what should we do? Anyone wants to take guess? What function we need to use, or what aggregate function we need to use, or any statement? Just base, don't worry whether it is right or wrong. All right. So here, if you see, the point that I wanted to tell you is we need to count, because they are saying we need to find the number of users who purchased a product on multiple days. So we need to count the number of days. Okay, we need to count the number of days, right? But at the same time, we need to count the number of days which are distinct, which are unique. After counting unique days, it has to be more than one. After counting unique days, it has to be more than one for every user, right? So we need to group by user and we need to count unique days. Then more than one means it will come in the output. Can somebody now, anybody is getting an idea, vague idea what can be the query, final output query? Okay, so it will be, this is how it will be. Select users, group by users, that's what I talked about, right? And having count of unique days, which is nothing but distinct. So inside the count we need to put distinct. So distinct, when we put distinct, when we group by U1, if you see U1, both dates are same. When we put, when we say two records of same day will become 1, right? 1. So count becomes 1 only. So when we say greater than 1, so the U1 will not come in the output, because that will be equal to 1 will not come in the output. Only if it is greater than 1 will come in the output. Okay, so obviously U2 and U4 will come in the output. Any question guys on this answer? I explicitly took this question because I want you guys to learn that, because already I have covered in the class, right? In the sum, in the count, we can use distinct inside. So this is the real life scenario where you can use distinct. Okay, I am going to take about the second interview question. Okay. So in this interview question, there is an input table and there is an output data. So here I think pretty much, I hope somebody will attempt. Okay, so here this is employee wise employee table, employee wise employee name, everything is there, employee salary is there, and also manager ID is there. Manager ID is also there. So what the output is expected is, manager wise team's average salary, his team's average salary. Okay, so it's a team's average salary. Okay, so based on the employee we can find out the manager. Then for example, if you see for manager 17 is Raman. For Raman the team average is Santosh salary, because he is the manager, and Nidhi, right? So 60,000 plus 65,000, so average if you find out, you will get 62,500, right? That is the average for his team's average. So now how can somebody tell me how we can get this output?
We'll do an average of salary, but group by manager ID.
But group by manager ID will get you these two. First and last will get you. But how do you get the manager name?
Join, sir. Join put manager.
Which join?
Inner join, sir. Manager ID.
Inner join. What is the specific join?
Manager ID, input data manager ID and output data manager ID.
Output dot manager ID. Input data manager ID is fine, but எந்த ரெண்டு டேபிள் இருக்கும் அந்த ஜாயினில்? வாட் இஸ் டேபிள் ஏ, வாட் இஸ் டேபிள் பி?
டேபிள் ஏ ஃபார் எக்ஸாம்பிள் இன்புட் டேட்டா
Ah.
அதில் வந்து மேனேஜர்
Okay. Table B.
So self join.
Yes. That's what I was. Yeah, self join. Yeah, thank you, Janikram. A good attempt, Vignesh. So it's a self join, right? So we need to go for a self join. Then we need to do group by. For example, employee A and employee B. Self join we will be going. Okay. So self join we will be going. Okay, and then we will be doing the same example that we talked about, and we will get the manager ID and manager name, and then average salary we will do for all these team members. Okay, so that's how we will be getting. Yeah, it's a good attempt, guys. Good one. So now I'm going to share few SQL tips. Okay, I'm going to share few SQL tips. So it's called simplified approach. Okay, I don't know whether you guys have seen the YouTube. I already have shared this video. It's a 20 minutes video. It's an important one, guys. You guys can share. You guys can watch it. I will briefly talk about it now. Okay, so what we should do whenever you see a question, I think even the previous two example that I shared, right? Whenever somebody gives you a question in interview or in real life, you should not directly jump into writing SQL. You should not be thinking SQL. You should think how to interpret. First you need to interpret the question. Okay, this question needs some aggregation, group by. This question they are asking us to filter this. They are asking us to select this information. Okay, so like that we need to think. It's called interpretation. Analyzing the question, interpreting, trying to interpret the question. What exactly is being asked? Okay, and then you need to inspect the table that we have, what data we have, right? Do the inspection. So what all columns are there? Is it nullable? Is it not nullable? What is the relationship between two tables, right? Whether we have the data stored is in employee level, manager level, what data we have. It's more of inspecting the table and column data that we have with us. This is interpreting the question. Okay, and then third is infer. Infer is now you are logically thinking and coming up with the solution, not technically. You are not going to think about group by logic and the technical. No, without technical, non-technical, logically you are coming up with the solution. Okay, so because in this example, if you remember what I told, right? So you need to think, right? You guys also thought about that way. So we need to group by. So obviously when I need to come up with the solution, I need to go for group by. So logically I need to group the logic, get the team's average salary. Also I need to go for a join to get the manager. So to that level we need to think. Okay, that is what is infer. Generating all possible solutions, evaluate them, and choose the best option. And now once you infer, now only you think about implementing, thinking technically. Okay, so for this solution I need to use this SQL statement, I need to use group by, I need to use order by. Like that we need to think. Okay, so I have a detailed YouTube, guys. I think I will share it maybe today later. So watch that video. I also have given one example. So using the same SQL simplified approach, I have taken up an example step by step. Interpret what I do for that question, inspect what I did, infer what I did, and implement what I did. I have given them step by step. I will share on YouTube. You guys can go through. You will get an idea. Okay. Any question on this slide? Because many people, right, they know SQL, they know in and out. Okay, this statement order by, I need to what it does, right? They know exactly inner join, definition wise they know, theoretically they know, but they will not be able to solve the problem, right? Because they don't follow this step by step approach. So immediately after reading the question they will think about SQL, right? So skipping all these three steps, it is difficult, right? So for simple questions it's you will manage, but as the complexity increases, it's difficult for you to jump from directly question to implementation, right? So it will be overwhelming and you will be confused, right? That is where people struggle and give up. So but my suggestion, my recommendation is, whichever SQL interview question or the real life your problem solving, you are going to solve SQL problem solving, go with this 4 I's, right? 4 I's. First I is interpret, inspect, infer, and implement. Okay, so try with this approach. I'm sure you will be able to find it easy, because it's a procedural, it's a process, right? It's a process. You will be able to scale to any level. This is the final slide, guys. SQL query construct consideration. Okay, so what all we need to consider for a business question? First we need to write a query, right? So first we need to write a query, try to write a single query to solve the question. But in some situations single query may not be possible. Okay, subqueries, you need to write subquery, okay, to get intermediate result. Then only you will be able to solve the answer. So then go for subquery. Okay, and then after the, even after writing subquery, you may notice the same kind of intermediate result is needed in multiple places within the query. The same let's say the rejection ratio is needed in 2-3 places in a query. Better go for common table expression, because you compute it once and use it multiple places within the query. If the same rejection ratio is needed in multiple places, multiple queries, you better create it as a view, right? You better create it as a view so that you can access it in different queries. Okay, and if the view is taking time to execute, get you the output. Okay, if it is time consuming, 2 minutes, 1 minute, the end users are not happy because it's a critical view, then what you can do, you can make it as a materialized view. Materialized view, which we did not cover, but it's a special type of view wherein it locally creates a data, locally stores the data. Okay, it does not execute the underlying SQL query. It executes a SQL query once and it caches the data. Okay, it is little advanced topic for the performance DBA or performance related, so I have not covered, but this is the approach generally people will be going. Okay, but if the underlying table frequently changes, we cannot keep on building. The cache will become outdated, right? So whatever the locally it's storing will be outdated if the underlying table data gets changed frequently. So in that situation, it's better you create this as a table. You need to push the logic to the table. Okay, this is how you will think, right from simple query to subquery to common table expression to view to materialized view to table. Okay, and for this also I think I have written one detailed slide. You just can go through the in I think LinkedIn also I published. So any question on this, guys? Okay, so with that we have come to end of the today's lesson. So I'm sharing important links. Okay, these are HackerRank. You guys might be knowing HackerRank or LeetCode. So these are famous websites wherein they will give you the editor to solve interview questions, right? Based on which you can secure in SQL. You can say especially if you take HackerRank, which is good, you can they will give you basic, intermediate, and advanced hard type of SQL interview questions. You can start with basic, beginner. Then once you solve, let's say 5 to 10 interview questions, then they'll give 1 star. Then you will go to 2 star, 3 star, like that you can go to 5 star. So that you in your biodata or resume also you can mention that I am a 5 star. My level is 5 star in HackerRank, right? People even in LinkedIn they say 5 star on LinkedIn on HackerRank. They put it in their biodata in LinkedIn also. So that's how you can start projecting yourself, right? Your technical skills, you can say you are an expert or you are an intermediate skills person, right? And this HackerRank, LeetCode kind of websites are really good with practicing interview questions. Okay, I'll share the link on the thing. So with that we have come to end of the lesson, and we have come to end of the SQL training course, the entire training course that we have come up with. And thank you so much, guys, for being with me. I think some folks joined very regularly. I'm really thankful for them, and I hope you guys really understood. And I have few asks. Okay, so few asks. First is, anybody has some question? I hear some noise, background noise. Anybody? Okay, yeah. Okay, thank you, Vignesh. And let me cover. So I have few asks. keep practicing, guys. Keep this skill forever. Okay, because practice makes progress. And then share your feedback on social media. So if you guys found my training is really good, and you guys it really helped you guys to learn, right? And you, some people, right, non-IT people, non-IT background people, right, felt no, they didn't have any idea, they didn't have any clue before starting the training, but after the training, right, they were comfortable writing queries, right? So if you felt that level of significant improvement, significant no kind of skills that you have acquired, and if the training is impact